Welcome to the course of differential equation. In this session, we will discuss about the Euler-Cauchy equation part 3. We already discussed about the Euler-Cauchy equation, and we know that the Euler-Cauchy equation with the constant coefficients as x square y double dash plus axy dash plus vy equal to 0 is a Euler-Cauchy equation with the constant homogeneous Euler-Cauchy equation with the constant coefficients. To solve this equation, we write the auxiliary equation as x m square plus a minus 1 into m plus b equal to 0 is the auxiliary equation. Here axy dash is there, therefore, here we have a minus 1 into m plus b equal to 0. See, as we discussed in the case of the solving homogeneous linear second order differential equation with the constant coefficients, here we have 3 cases may arise, because this is a quadratic equation, as because that is a second degree quadratic equation that may have 3 choices, that is the discriminant may be greater than 0. So, in the case of if the discriminant of this equation is greater than 0, therefore, there will exist 2 real and distinct roots m1 and m2 is there. So, in the case of that, the general solution will be y is equal to c1 x raised to m1 plus c2 x raised to m2. See, before in the case of the constant coefficient linear differential equation, we discussed it is that c1 e raised to m1 f x and c2 e raised to m2 f x. Instead of that, here we have c1 x raised to m1 plus c2 x raised to m2 as a solution of the quadratic equation, as a solution of the this one Euler-Cauchy differential equation. If the discriminant is equal to 0, if the discriminant is equal to 0, so in this case we can say that if the discriminant is equal to 0, in this case we will have this is equal to the solution, the roots of the auxiliary equation m1 is equal to m2 is equal to m. Therefore, we can have the general solution as the general solution of the differential equation is y is equal to c1 plus c2 log x into x raised to mx. See, before itself c1 plus c2 x e raised to mx. Instead of that, here in the case of Euler-Cauchy equation, we will have the general solution as c1 plus c2 log x e raised to, instead of e raised to mx, here we have x raised to m is there. Okay, fine. So, the third one is if the discriminant is less than 0. Okay. On that case, the solutions are m1 is equal to p plus iq, or some for the convenience I would like to take it as mu plus I nu, and m2 is equal to mu minus I nu is there. Okay. The roots are the complex conjugates. Therefore, in this case the general solution is y is equal to x raised to mu okay, is there if the mu is the real part of this this one complex root, this is the real part, and nu is the imaginary part of this complex roots. Okay, x raised to mu a cos nu log x plus b sin nu log x is there. See my dear students, here we have 3 choices are there for the solution of the differential equation. If the discriminant of the auxiliary equation m square plus a minus 1 into m plus b equal to 0 is real, maybe greater than 0, then we will have real and distinct solution. We will get the general solution as like this, and if the discriminant is equal to 0, then we will have the double root is double root for the auxiliary equation. Therefore, we will have the general solution like this. Okay. Finally, we will have, if the discriminant is less than 0, we will have the complex conjugate roots for the auxiliary equation. Then the general solution is like this: x raised to mu a cos nu log x plus b sin nu log x is there. Okay, dear students, we can move to a question. In example 1, we will discuss about solve the Euler Cauchy equation. Solve the Euler Cauchy equation: x square y double dash x square y double dash x square y double dash plus 0.6 xy dash plus 16.04 y is equal to 0. Say x square y double dash plus 0.66 y dash plus 16.04 y is equal to 0. See my dear students, while seeing the equation, we understood it is that keeps the general form of the Euler Cauchy equation. So, definitely this is Euler homogeneous Euler Cauchy equation with the constant coefficients. So, to solve this equation, we can write the auxiliary equation. See, what about the auxiliary equation? Auxiliary equation. Okay. The auxiliary equation is actually m square plus a minus 1. Here see who is a? The a is actually 0.6 and b is actually 16.04. Okay. So, we can write the auxiliary equation as m square plus a minus 1 into m plus b is equal to 0. Okay, fine. Therefore, we have m square plus a minus 1, that is equal to 0.6 minus 1 into m plus b is actually 16.04. 16.04 is equal to 0. Okay, fine. Therefore, we will have the auxiliary equation as m square plus 0.6 minus 1 is actually minus 0.4 m plus 16.04, okay, is equal to 0, okay, plus 16.04 is equal to 0. Fine. Okay. So, now this is our auxiliary equation. This is our auxiliary equation. Now, we can solve by using the equation m is equal to, okay, m is equal to minus b plus or minus root of b square minus 4ac by 2a. Okay. Here this is a is the coefficient of x square, okay, b is the coefficient of x, c is the constant term. C is the constant term. So, dear students, we can come back to here why I just wrote that is there here in this sense a and b is different than the normal differential equation. We just used a and b and c here based on the general form of the auxiliary characteristic equation, that is the quadratic equation that we discussed before. Okay, fine. So, the value of a here for this particular case, for this auxiliary equation, I just restate that the value of a as here a is equal to this one 1 and b is equal to 0, sorry, b is equal to minus 0.4, B is equal to minus 0.4 and C is equal to 16.04. C is equal to 16.04. Okay, dear students, so we will have the values m is equal to minus b, that is equal to minus 0.4 plus or minus the value of b square, that is minus 0.4 square, that is 4 into 4 16, 2 decimal points we have to make it place. So, 0.16 minus 4 AC, 4 into 1 into the value of C is actually 16.04 divided by 2 into 1. Okay. So, this is equal to minus 0.4 plus or minus 0.16 minus 4 times of 16, 4 times of 16 is actually 64. 4 times of 0.4 is actually 0.16. So, we will have the value is equal to minus 64.16 divided by 2 is there. Okay, fine. So, we will have minus 0. This is equal to minus 0.4 plus or minus root of 0.616 minus 64.16, while subtracting that is from there we will have minus 64 is here divided by 2. Okay. So, finally, we will have this is equal to 0.4 plus or minus root of 64, this is equal to I into 8 is there, but divided by 2. Fine. Finally, while this one dividing this with 2, 0.2 plus or minus 4I, okay, is the solution. That is m1 is equal to minus 0.2 plus 4I and m2 is equal to 0.2 minus 4I is there. Okay. See, dear students, which is actually P and Q. This is equal to value of mu is 0.2 and value of nu is actually 4 is there. Fine. Okay, the auxiliary equation have got the roots are complex conjugates. Since because of the discriminant, here we have the discriminant which is negative less than 0. Therefore, we have the roots are complex conjugates. The roots are complex conjugates. The roots are complex conjugates. See, dear students, think about the general solution. See, what is actually the general solution is we already discussed here as general solution as y is equal to x raised to mu a cos nu log x plus b sin nu log x is there. So, dear students, we can write this is equal to, so the solution is, therefore, the general solution is actually, therefore, general solution is y is equal to x raised to mu a cos nu log x plus b sin nu log x. Okay, fine. Therefore, this is equal to, therefore, that is y is equal to x raised to the value of mu is actually 0.2, x raised to 0.2 a cos nu, the value of nu is actually 4. Therefore, a cos nu log x, that is a cos 4 log x plus b sin nu log x 4 log x. Okay, fine. This is the general solution of the given Euler Cauchy differential equation. See, my dear students, they have many choices for the Euler-Cauchy differential equation. This is what we did here. It is very nice Euler-Cauchy equation. And also here we did not mention about any of the initial conditions or boundary conditions. Therefore, it will remains like general solution. They have no provision to find out the particular solution. So, we can move to one more question. It is that, so example 2, solve Euler-Cauchy differential equation x square d square plus 7 x d plus 9 I into y is equal to 0. See, here we use the differential operators x square d square plus 7 x d plus 9 y is equal to 0. Okay, dear students, we will have the solution as this is actually the differential equation is actually x square y double dash plus 7 x y dash plus 9 y is equal to 0. Okay. This is the homogeneous Euler-Cauchy equation with the constant coefficients. Instead of A, here we have the value 7, instead of B, here we have value is 9. Okay, fine. So, we can write the auxiliary equation as y x square y double dash, that is equal to this is m square plus a minus 1 into m plus b equal to 0. We have the value of a is m square plus 7 minus 1, that is equal to 6 m plus the value of b is 9 equal to 0, that is m square plus 6 m plus 9 equal to 0, which is actually m plus 3 the whole square. Therefore, this is equal to m plus, that is m plus 3 the whole square is equal to 0, that is m is equal to minus 3 is a double root, m is equal to minus 3 is a double root. So, it have a double root. Therefore, we have the formula for the general solution as we discussed before, it is that is actually as we discussed before, it is actually y is equal to C1 plus C2 log x raised to m is there. So, dear students, will have the general solution is actually, therefore, the general solution of given Euler-Cauchy differential equation is Euler-Cauchy differential equation is y is equal to C1 plus C2 log x into into x raised to m. Okay, fine. So, we will have y is equal to C1 plus C2 log x is there, log x raised to the value of m is equal to minus 3 is the general solution of the given differential equation, is the general solution of the given differential equation. Fine. See, my dear students, we can move to one more question. Example 3. In example 3, write down the question: 4x square d square. Solve the Euler Cauchy differential equation for x square d square, for x square d square minus 8 x d plus 5 minus 8 x d plus 5 I into y is equal to 0. Okay. See, dear students, this is actually the equation is for x square d square minus 8 x d plus 5 I into y is equal to 0. See, the equation is actually for x square y double dash minus 8 x y dash plus 5 is equal to 0. Okay. So, to make it as the general form of the Euler Cauchy equation, we just divide the entire equation by 4. So, we will have the equation as x square y double dash plus minus 8 by 4, that is 2x y dash plus, actually this is equal to 5 divided by 4 plus 5 by 4 is equal to 0. Okay, fine. So, here we found the values. Now, we got the general form. This is the minus 2 is actually value of A and 5 by 4 is actually the value of B. Now, we have the Euler Cauchy equation. We got the standard form of the Euler Cauchy equation. So, we can write the auxiliary equation as part of solution. We can write the auxiliary equation as m square plus a minus 1 into m plus b equal to 0. Okay, fine. So, we can replace the value of a and value of b. So, a is actually minus 2, a minus 1 minus 2 minus 1, where b is actually 5 by 4 is there. See, dear students, we can write this is equal to m square plus minus 2 minus 1 into m plus b is actually, the value of b is actually 5 by 4 plus 5 divided by 4 5 divided by 4 is equal to 0. Okay, m square minus 3m plus 5 divided by 4 is equal to 0. Okay, fine. So, we have to find two values. While multiplying them, we will get the value is equal to 5 by 4, and while adding them, if we get the value is equal to 3. See, think about such kind of two values. Okay, see, think about 5 by 2 into 5 by 2 into 1 by 2. 5 by 2 and 1 by 2 are two values. 5 by 2 into 1 by 2, that is equal to 5 into 1, that is equal to 5, divided by 2 into 2 is 5 by 4. See, think about this one, 5 by 2 plus 1 by 2, that is equal to 6 by 2 is equal to actually 3, but we have to get the minus 3. So, we can just change the sign as like this. See, we can just change the sign as minus 5 by 2 and minus 1 by 2. While multiplying negative with negative, we will get the positive value. While adding two negative values, minus 5 by 2 and minus 1 by 2, will have the negative 6 by 2. Finally, we will have the value is equal to negative 3. So, okay, fine, we are happy, we got two values. This is actually m minus 5 by 2 into m minus 1 by 2 equal to 0. Fine, we got the values m minus 1 by 2. Therefore, that is m is equal to 5 by 2 and m is equal to 1 by 2. We got the roots of the auxiliary equation. The roots are real and distinct. Fine, we have the general solution. See, dear students, we found the general, we have the formula for general solution. Because of this discriminant is greater than 0, you will get the real and distinct values for roots for the auxiliary equation. We will have the general solution as C 1 x raised to m 1 plus C 2 x raised to m 2. Okay, fine, students. So, we will have the general solution as, okay, we will have the general solution as, fine. So, we will have the general solution as, therefore, general solution of given Euler Cauchy, given Euler Cauchy differential equation is y is equal to C 1 x raised to m 1 plus C 2 x raised to m 2. C 1 x raised to m 1 plus C 2 x raised to m 2. Therefore, that is y is equal to C 1, the x raised to m 1 is actually 5 by 2 and m 2 is actually 1 by 2. C 1. So, we will have, dear students, C 1 x raised to 5 by 2 plus C 2 x raised to 1 by 2 is there, is the general solution of the given Euler Cauchy differential equation. So, dear students, there are many such kind of the questions are available in our different form of the many materials of the differential equation. I will give you some assignments, try to solve this assignment question. That will be, sorry, that will make you more clear about the Euler Cauchy equation. So, dear students, we will have, this is equal to the first question, solve the Euler Cauchy equation, that is equal to x square d square plus 5 x d plus 5 x d plus 4 I into y equal to 0. Okay. The second one, solve the Euler Cauchy equation, x square d square plus 1.25 plus 1.25 into I y is equal to 0. Right, one more question, solve x square d square plus, sorry, minus 5 x d plus 4 I into y is equal to 0. Okay. Try to solve these questions, that will make you more clear about Euler Cauchy equation. Also, you can solve use the initial conditions also, that on that case you will get the particular solution for the differential equation. Thank you for watching this video. Continue watching. Thank you very much.